Good morning, my fellow chemists. If you clicked on this video, it probably means one of two things. Either you know ionization energy and you just need a bit of a review, or you have a test tomorrow and you have no clue what it is. Either way, in this video, I'm going to be breaking down everything you need to know, so stay tuned. So, what really is ionization energy? Simply put, it's the amount of energy that it takes to remove an electron. So here we have this lithium atom, and its ionization energy is the amount of energy it takes to remove this electron, which then turns it into this lithium ion. Okay, but what is an ion? All an ion is an atom or molecule with a net electric charge due to the number of protons and the number of electrons not being equal. We see this in hydrogen here, as it becomes positive by losing an electron and thus gaining a positive charge. The general trend for ionization energies tends to be that as you go towards the top right, you find higher ionization energies. In other words, it's very difficult to get rid of that electron. Whereas as you go towards the bottom left, you find a lot lower ionization energies, so it's very easy to get rid of it. The reason for this periodic trend has to do with each element's valence electrons, or outermost electrons. Every element wants to become stable, and thus the easier it is for it to become stable by losing an electron, the lower its ionization energy will be because it increases its stability. Now let's take the group 1 elements for example. They each have one valence electron, which means that they only need to lose one single electron in order for them to have the same electron configuration as the noble gases, which is a full set of electrons and very stable. Due to this, group 1 elements really want to lose their valence electron because it'll make them more stable. Thus, the energy required to remove the electron, or the ionization energy, will be very low for elements in group 1. On the other hand, we have noble gases. Now, these gases do not want to lose any valence electrons because they're already as stable as can be, and if we try to get rid of any of their electrons, they'll become less stable. This means that they will have very high ionization energies. Remember that as you go down a group, the atomic radii of the elements increases. This is because they have more shells. Now, what this means is that the distance between the protons and the electrons is going to be much greater, and thus the amount of energy, the pull the protons have on the electrons is much less. Okay, now we know why ionization energy increases when moving across a period, but why does it also increase when we're moving up a group? Well, allow me to introduce to you Coulomb's law. Coulomb's law is basically the Bible for periodic trends. It can basically explain everything. So this here's the formula. Don't freak out. You do not need to ever know how to calculate using it. You just need to understand what it means and what it does. Now, ionization energy depends in part on how close the electrons are towards the positively charged nucleus, because the protons in the nucleus are attracting the electrons. So, if they are closer together, that means that they exhibit a stronger force on the electrons and won't let go. Whereas we have lithium over here. Now, its valence electron that it's trying to get rid of is much further from the nucleus than helium's is. So this means that it will have a lot less energy required to get rid of it because it's so much further away. The protons exhibit a lesser amount of force on it. Remember, all ionization energy is the amount of energy it takes to remove the electron. So, lithium will have a lower ionization energy because it takes much less force in order to remove its electron. Now, as we go across the period, we seem to see that the atomic radius actually gets smaller. Now, this is because we increase the amount of protons that we keep going, and they stay in the same shell. So that means that they're at roughly the same distance, however, there's a greater charge pulling them in. So remember, ionization energy is directly tied in with the size of the atomic radius. When you look at the periodic trend for atomic radius, you actually see that it's the exact same of ionization energy, and that's no coincidence. As you have a smaller atomic radius, you have a larger ionization energy, and vice versa. So here we have the calculated energies for the first ionization energy, and it's exactly what we had expected. As we move across the period, we find higher ionization energies due to it being closer to a full electron set and because of smaller atomic radius. Whereas as you start increasing the atomic number and thus moving down a group, you start to see that the ionization energies are lower because they have larger atomic radiuses, and this allows for lesser Coulombic forces and thus lower ionization energies. Now, what's really interesting is that we see that there are some spots that seem to have a little dip in the ionization energy that we wouldn't expect, and I'm not going to go too far into detail as why this is in this video. However, it has to do with the stability of the atom. The reason for this is due to the fact that certain electron configurations can be more stable than others, and this comes into play regarding the Aufbau principle and Hund's rule, but you don't really need to know that much about that. Instead, just know that there are certain areas that are more stable than others. Okay, but what exactly are the areas that give special stability? Well, elements are more stable if they've completed a S, a D, a F, or a P orbital, or if they have half of a D, an F, or a P orbital completed. So just make sure that you watch out for these special cases. If you get a question that has a half-filled or completely filled orbital, know that it's most likely going to be greater than the next one. It goes opposite to what the general trend says. So here's a summary of everything that you should know by now. All elements want to become stable, and they lose electrons in order to become more stable. If an element is already very stable, it will resist losing its electron, and thus will have a very high ionization energy. Ionization energy is directly related to the atomic radius of the element, because as you increase the atomic radius, you decrease the Coulombic forces, and you decrease the ionization energy. Halfway and completely filled orbitals increase the stability of the element and also the ionization energy. My name was Caleb, and I hope that this was helpful.